Hi, today we're going over section 4.4 quadratic functions of a form y equals ax minus p squared plus q, and finishing the second half of this section. So what we'll be doing is creating equations from graphs or if we're given key points. If we're given a vertex on one other point, we'll substitute our vertex into our equation we learned about yesterday for P and Q, then substitute another point in for X and Y to solve for A. So our first example, write the equation for the parabola with a vertex at -4, -5, and goes through -2, -1. Now this is our vertex, so we know that this is our P value. We know that this is our Q value. So we have Y is equal to A, X minus P squared plus Q. We'll fill in the information we have for P and Q. So we have AX minus a negative, so it becomes +4 squared minus 5. Now we need to figure out our A value. To do that, we will put in any other point on our graph. So we'll use this point they gave us. So we have a Y value of -1 and an X value of -2. And then gradually rearrange. So add 5 to both sides. So 4 is equal to A times 2 squared. So 4 is equal to 4A. Divide both sides by 4. 1 is our A value. Now, because A is just 1, we can simply take this equation and rewrite it without A value, because 1 times anything is itself. So we'd have Y is equal to X plus 4 squared minus 5. If our number is anything other than an A, it would just go in front right here. So if our number is anything other than 1. Okay, so next, if we're given an axis of symmetry and 2 points, what we can do is we know the axis of symmetry goes through our vertex, so we can insert our axis of symmetry value for P. Then we'll create 2 equations with the 2 points to then solve for A, and lastly, we'll solve for Q. Okay, so for example, write the equation with an axis of symmetry of x equals 1 and goes through 2, 5 and 4, 37. So like I said, our axis of symmetry is our P value. So we'd have our general equation y equals A x minus P squared plus Q. We'll fill in our P value. So we have y is equal to A x minus 1 squared plus Q. We'll then substitute these 2 points into our equation into 2 separate versions of this, and then rearrange and solve for our A value. So the first one, I'll substitute the 2 and 5 in, so I've got 5 is equal to A times 2 minus 1 squared plus Q. So this gives us 5 is equal to 2 minus 1 is 1, 1 squared is 1. So 5 is equal to A plus Q. I'll move the A to the other side. So I've got 5 minus A equals Q. Now I'll do the same thing using the point 4, 37, and I'll rearrange to get Q on its own. So I have 37 is equal to A times 4 minus 1 squared plus Q. So that gives us 37 equals 4 minus 1 is 3, 3 squared is 9, so 9A plus Q. I'll move the 9A to the other side. So that gives us 37 minus 9A equals Q. Now in both these equations, Q is equal to the same value, which means that these 2 equations must be equal to each other. So we have 5 minus A equals 37 minus 9A. We'll then rearrange and solve for a. So I'd add 9a to both sides and subtract 5 from both sides. So that gives us 8a is equal to 32. We divide both sides by the 8. We get an a value of 4. Now that we have our a value, we can substitute in either one of these equations and it will give us the same q value. So we've got 5 minus a equals q. So we have 5 minus 4 equals q. So we have 1 as our q value. Now that we have our p, q, and our a values, we can write our formula. So we have y is equal to a, x minus our p value of 1 squared plus our q value of 1. So this would be our equation. Okay, so practice for this section is on page 306.